In this video, we will review the basic concepts of repeated measures analysis and go through an example in SPSS. Why is it important to cover repeated measures? In many settings, measurements are taken on test subjects over time or over different test conditions. This is particularly true in longitudinal studies. When repeated measures are taken on the same test subject, we would expect these measurements to be related. They cannot be assumed to be independent. We know that people have different individual differences. For example, blood pressure, pulse rate, cholesterol level. Consider an intervention study to reduce cholesterol. If one test subject's total cholesterol is high, say at an initial reading of 250, and if the intervention is effective, then you might expect a reduction to a cholesterol level of 240 at the second reading. But another test subject may have an initial cholesterol of 230, and their second measurement may be 222. Repeated measurement techniques account for observations that are not independent over time or over different conditions. You have already encountered repeated measures in your first statistics course. A paired t-test is a repeated measures method. When comparing two groups or two conditions that are naturally paired, we subtracted the two measurements and analyzed the difference. The subtraction removes the variation due to individual differences. When you hear a new diet product advertised, the claims are for a weight loss of, say, 40 pounds. If instead they said, I weigh 150 pounds now, you wouldn't know the person lost 40 pounds unless you knew their initial weight was 190. When comparing a paired comparison to two independent samples designs, there are a number of differences to note. In two independent samples, or a between subjects design, a test subject will be assigned to one of two groups and will have one measurement. In a paired comparison, or a within subjects design, a test subject will be measured twice. The point estimate for an independent samples comparison will be the difference of two means, the means of each group. In the paired comparison, the difference is taken between the readings of each group and the average of those differences is taken. In independent samples, the error estimate contains the variability due to the individual differences. For the paired samples, the variability due to individual differences is removed by the subtraction of the two readings. Let's now turn our attention to situations where we look at comparing more than two groups or two levels. In these cases, we use analysis of variance. The statistical model for an independent samples ANOVA partitions the variation in the response into a portion due to the independent variable, the treatment or the model, and the portion due to error. So an outcome is modeled as an adjustment to the grand mean due to the treatment plus an error. The method for comparing more than two groups or conditions when the assumption of independence does not hold is repeated measures analysis of variance. In this case, we partition the variation in the response into the same two components plus an additional component that accounts for the individual differences in test subjects. So our model for repeated measures ANOVA will have two adjustments from the grand mean, one for the treatment or model and one for the test subjects, in addition to the error term. Let's look at an example of repeated measures ANOVA with one factor. We want to understand differences in heart rate, the outcome, based on type of stressor, the predictor. There are three different stressors: pain, an arithmetic task, and a social role play. There are 6 study participants, and there will be 4 measurements on each participant. Heart rates at baseline with no stress, and then with each of the 3 stressors. Here's the data. You can see that there are differences at baseline between the different test subjects. There also appear to be differences between the treatment means. Heart rate has been measured on each test subject under different conditions, and since there are more than two conditions, a repeated measures analysis of variance is the appropriate analysis method. Now we'll go through how to run an analysis of repeated measures ANOVA in SPSS. I've opened the data file in SPSS, so go to Analyze, General Linear Model, Repeated Measures. The factor we want to rename to stress, and we have 4 levels, and that includes the baseline. And we'll add that, and this defines our repeated measures. We want to move each stressor into the within subjects variables dialog. Under contrasts, we want to select simple, and the reference category is first, and change that and continue. This method of analysis is slightly different than what's shown in the book, and we'll discuss more about this in subsequent slides. We're going to now say OK, and we have the analysis. In the next slides, we'll go through the results and interpret the key pieces of output. In the next 3 slides, we'll interpret the results of the repeated measures one-way analysis of variance for the heart rate data. Here we show the test for sphericity. The null hypothesis is that there is sphericity, and the alternative is that there is no sphericity. In this case, the p-value is 0.985, which indicates that the sphericity assumption is satisfied. Sphericity is analogous to the assumption of equality of variance for independent group designs. In the example in the field text, the sphericity assumption is not satisfied, which leads to a more complicated analysis. Because in our example, the sphericity assumption is satisfied, we will take a slightly different analysis approach. In this slide, we test the hypothesis that the means of all 4 groups are equal versus an alternative that at least one mean is different. Since the sphericity assumption is satisfied, we will use the first line. The upper part of the chart gives the sums of squares and mean square associated with the effective stressor. The lower part gives the error sum of squares and the mean square error. In the upper portion of the chart, on the first line, we see that the F ratio and the associated p-value of 0.001 for the test. So we conclude that there is a significant difference in mean heart rate for at least one of the stressors. And finally, we show the contrast table, which compares each of the 3 stressors to the baseline heart rate. In this table, we see that both pain and role-playing are significantly different from the baseline heart rate, and the math task is not. So I guess that's an important conclusion, that math is not stressful. I don't know if we could say the same about statistics. We'd have to gather the data. This video has given you an introduction to repeated measures. In healthcare applications, repeated measures are often encountered. These methods take into account individual differences in test subjects. We have looked at the most basic of repeated measures techniques. There are other techniques that can be used in more complicated situations.